Welcome back, BC Calc students. Mr. Record here from Avon High School, and I'm joined by my awesome Period 4 class. If they want to give a shout out, they can. Yeah, that was impressive. That was impressive. So we are still in the middle of topic 615. 615, remember, is this fictitious numbered topic that I throw in at the end of Unit 6 to take care of a lot of really complicated and interesting integrals that you probably won't see. You definitely won't see on the BC exam, but you very likely would see if you were taking a Calc 2 class. So we're still talking about trigonometric integrals, and this example kind of similar to example 4. They're sister problems, and if you haven't seen example 4, and this is the first go around with tangents and secants, I would say stay with this video and you could watch it first, but you definitely want to go back and watch example 4 at some point to see how the two of these examples differ just a little bit. So can we talk about an odd tangent and an even secant? Let's take a look. Our problem is going to ask us to integrate the secant fourth power of 3x times the tangent cubed of 3x. And one of our mottos, one of our mantras, if you remember, is the fact odd is evil. Odd exponents are evil. Those are the things that we want to take care of. Why? Why is odd evil, you might ask? I'm glad you asked. Well, if we have an even power of tangent or an even power of secant, we have the luxury of being able to use some identities, some trig identities, some Pythagorean identities, and that's what gets us into the problem. So if you remember from before, whenever we see an odd tangent, like in this case, we're going to peel away that tangent, all right? Now, I'm not going to just stop there. I'm going to also peel away a secant. Whoa, wait a minute. What? Is that what I want to do with this? Well, let's see. If I peel away, let me write this again. Secant cubed of 3x, and then I've got tangent squared of 3x, and then if I have a secant and a tangent that I've peeled away, what good is that going to be? Well, that secant 3x, tangent 3x that we're writing here, this is what we would really like to play the role of our du. So we have to think about, if that's going to be the du, what is it that must be the u? What do you take the derivative of to create this secant tangent? And the answer to that is a secant. And that's okay, because we have this secant factor here, albeit raised to the third power. That's fine. But what the heck are we going to do about this tangent squared? So just like the previous example, we rely on a really nifty trig identity that looks like this. The identity says that 1 plus the tangent squared of theta is the secant squared of theta. I'm just going to use theta in general. If I have tangent squared of 3x, then that's just equivalent to the secant squared of 3x minus 1. You see how the theta is acting like the 3x here? So if I rewrite this, I now have secant cubed of 3x multiplied by 1 minus, I'm sorry, let's do that again. Secant squared 3x minus 1. Hopefully that makes sense there, right? Tangent squared, secant squared minus 1. In this case, I'm using 3x as the argument. And yep, I still have this secant 3x, tangent 3x sitting around here. Now I think the stage is set. I would actually give a fair amount of partial credit for this setup because you're definitely on your way. Now, if you see that u is going to be the secant of 3x, we have to take this derivative, use the chain rule. So not only is the derivative of secant going to be secant tangent, right? We're going to have secant 3x times tangent 3x, of course. But we have to take the derivative of 3x, which just puts a stray 3 out in front. That's not a big deal, right? I know we don't want this 3 to be part of the du, so we can fix that by placing a 1/3 out in front of the integral. And then since we've already said that u is the secant of 3x, by the time we replace each of these secant terms with that u, we have u cubed multiplied by u squared minus 1. And then our du drops straight down. Again, the du, oh darn it, it has a 3 involved with it, but by multiplying by that 1/3, we've canceled it away. Now, don't forget some of the easiest integration properties or procedures that you guys have learned in the past years that you've been taking calculus. Here, you're just going to distribute u cubed. So by the time that's distributed, you have u to the 5th minus u to the 3rd du. And if we integrate that, it's a pretty simple procedure. U to the 6 over 6 minus u to the 4th over 4. Might as well put our plus c in now. I know we're still going to have to back substitute, but kind of starting to think about that plus c now is going to be a good idea. And at this point, yep, all you do is you replace your u with secant 3x. And I'm not even going to worry about having us do any more simplification for this because it's overrated. It's not really necessary. Getting a common denominator doesn't really make this look all that much better. So you can see how I nestled the 6th power and the 4th power alongside that secant word, and I will have an equivalent answer here. Now, if you remember back in example 4, if you've watched that video, we actually took our result. Actually, we did this first. We took the original problem and we typed it into the calculator, a CAS calculator like the TI Inspired CAS, and we found out that the result looked very different. A lot of times the calculators are going to give you results that might have cosine words and sine words, but all you have to do is take those two answers, the one that the calculator gives you and the one that you computed, graph them on the same coordinate plane, and you'll see that the graphs do coincide. And I would challenge you guys to do the same for this to make sure that your answer does match. But that's our 5th example, dealing with trigonometric integrals, in this case, secant being even and positive with an odd tangent sitting on the side. Hopefully this helps out. We got several more videos over trig integrals. Be sure to check them out. In the meantime, keep studying calculus. We'll see you next time.